Okay, guys, indeterminate form. I'm trying to do this video in 5 seconds or less before my kids find me. Okay, check what would happen if we subbed x equals x.
My dinner's ready.
Oh my gosh. Okay, can you save me a seat? I'll be right there.
What are you doing?
Can you guys take my water cup down? I'll meet you down there in 5 seconds.
Take water cup down.
Okay, if we subbed in 1 into all the x's, let's check out the denominator. We would get 1 squared minus 3 times 1 plus 2. It would equal 0. So if we sub in 1, we'll actually get 0 over 0. Not good. But technically, in order for a limit to exist, it doesn't have to be defined at x equals a. So at x equals 1, it doesn't have to be defined, but it could still have a limit, as long as the limit's the same as it approaches from the left and the right. So one way of addressing this is to factor this equation. So this function is said to have removable discontinuity. So we could actually factor the top and bottom in this case. So we could find the limit as x approaches 1. And if we factor, we get x minus 5 over x minus 1. It's just a trinomial. And then x minus 2 over x minus 1. So then these guys actually cancel out, which makes sense because we're going to have a hole in our graph at 1. And we're left with x minus 5 over x minus 2. And now if we sub a 1 in, we will get 1 minus 5 over 1 minus 2, which is 4. Notice that as soon as we sub 1 in for x, we actually don't write the limit anymore because we've actually subbed 1 in. So that's just something to note. We always write this guy at the beginning of our expression, but then as soon as you sub the 1 into the equation, now you no longer need to write the limits part. So anyways, we've just found out that this function actually does have a limit at 4. Awesome. Okay, let's try another one. So let's say we had this. So same thing is going to happen. If we sub a 0 in, we're going to end up with 0 over 0. But we can actually avoid that by rationalizing it, like I told you in one of those videos. So I'm actually going to multiply the top of my expression by 4 plus x plus 2 and the bottom by root 4 plus x plus 2. And I'm just doing that to get it into a different form so that I'm actually able to evaluate this limit. So when I do that, the limit as x approaches 0, if I quickly factor or multiply the top 2 brackets out, I get a difference of squares. So that ends up being 4 plus x squared minus 2 squared over x times all that crazy stuff, 4 plus x plus 2. And if I simplify the top of that, those cancel. So I got 4 plus x minus 4 over x, 4 plus x plus 2. And then if I keep going, turns out 4 minus 4 is gone. These x's cancel. Okay. Sorry, guys. Dinner time at my house. So I get this. And then when I sub 0 in for x, I get 1 over 4. So this limit actually does exist. Just doesn't look like it right off the bat. That's what the indeterminate form is. You have to do some work before you can actually find the limit. Okay, last one. I'm going to get in trouble. Okay, now we're finding the limit as x approaches negative 3. So same problem. We'll get 0 over 0, blah, not good. We gotta do some work. So this time we're gonna actually try just expanding and factoring. So we don't really like this form it's in. Looks like the top is like in a weird, like what is that form? Something squared and there's a random minus 4. So if I expand 1 plus x squared, so I actually have 1 plus x times 1 plus x. So if I do this, then I end up with 1 plus 2x plus x squared minus 4 over x plus 3. And then if I collect like terms on the top, I'm going to rearrange it. So I got x squared plus 2x minus 3 over x plus 3. Now I'm going to factor it. So this would be x plus 3, x minus 1, adds to 2, multiplies to negative 3, that looks good, over x plus 3. Now these guys are going to cancel, which again makes sense because I'm going to have a hole in the graph at negative 3. So the limit as x approaches negative 3 of x minus 1 is equal to, -3 minus 1, which is -4. And we should note that since we did this, x cannot equal -3. Because it doesn't. There's going to be a hole in the graph there. And the same thing happened in the first one. The reason we were able to divide by x minus 1 is because x can't equal 1 in this situation either. There's going to be a hole in the graph right there. Or something where it doesn't equal that value. Okay, so that's indeterminate form. So just from first glance, if you try to like sub in a value for x and you get like 0/0 and you think, oh, there's no limit, there could be. So things you might have to do, you might have to factor. If there's roots, you might have to rationalize. Or there's a chance you have to expand and factor. Okay.